You know, it's just sad my parents aren't here. My mom passed away about a year ago, but if they'd been here, my father would have agreed and my mother would have believed it. Thank you, Doug. That was a lovely introduction. You know, it's lovely to be back. It really is. I retired in September of 2021. Almost just about 50 years after starting medical school in Albany in 1971. And I must tell you, it was a lot of wonderful years of hard work, and as much as I love that hard work, I love my retirement just as much. I've always, from the time I was a boy, I've always had heroes. For some reason, they tended to be scientists and physicians. I remember reading as a young boy about Louis Pasteur and Albert Schweitzer, and being inspired by their examples of discovery, of devotion, and of hard work and commitment to medicine. Anyway, when I got into otolaryngology, it was not surprising that I also found a hero to follow. And as I learned about Chevalier Jackson's work over the years, I became more and more amazed at his work and inspired by it. So today I'd like to tell you some of the story of Jackson, and particularly with a wife who's a lighting designer. Talking about the development of distal illumination was a natural for me, and this was clearly an important piece of our development of aerodigestive endoscopy, and that's what I'm going to talk about today. Now, I have no disclosures. I only do this for fun. The desire to gaze into the deep recesses of the human body has been an ancient quest. Realizing this goal into the practice of medicine didn't really occur until, in a way that was reproducible and safe, didn't really occur until the beginning of the 20th century. And it turns out that this is really a story about light. It's a story about understanding light, creating it, capturing it, directing it, and finally interpreting what is revealed. And that actually takes quite a bit of work. It's also a very human story. It's a story of genius, creativity, and one of compassion, but also of ambition and competition, but also very much of cooperation. It's the story how Chevalier Jackson established the discipline of bronchoesophagology as we practice it today. Now, in 1961, President Kennedy, in a presidential address to the nation, quoted a famous adage, aphorism, "Failure's an orphan, but success has 1,000 fathers." And indeed, the story I'm about to tell you today has many, many fathers, many, many men who devoted their lives to establishing our field. And perhaps the place to start is with Philip St. Physic, who is considered the father of American surgery. He is a graduate of the University of Pennsylvania in 1785, and then went to England and worked with John Hunter, the famous anatomist, vivisectionist, and surgeon, eventually becoming licensed and returned to the United States to practice at the University of Pennsylvania. He was a great inventor and innovator, and many of the tools you use today, such as your needle driver, were developed by Philip St. Physic. He used extensive use of autopsies, things like stomach pumps he brought into use, and for a pediatric otolaryngologist, he was the first to use a tonsilotome designed originally for removing the uvula, and don't ask me why, or you can ask it later. But anyway, he designed that to do a medial tonsillectomy, or partial tonsillectomy, otherwise known as a tonsilotome. Now, one of Philip St. Physic's students was a surgeon by the name of Samuel Gross. Now, Gross, in 1854, published a book by the name of Practical Treatise on Foreign Bodies in the Air Passages. 20 years after the publication of this book, Gross went on to write, it was the first attempt to systematize our knowledge on the subject, a pioneering work. Now, you may not recognize Gross from this photograph in this slide. However, you may be more familiar with this painting by Thomas Eakins called the Gross Clinic, and that's Samuel Gross. At this point, working at the Jefferson University Medical School. In terms of practice of surgery, is a direct heir to the legacy of Philip Singh Physic, and he's an innovator, inventor, prolific writer, and said to be a charismatic teacher. On the other hand, when you look inside the book that he writes on a practical treatise of foreign bodies in the air passages, what you see is that all of this was done through a tracheotomy. And his innovations were various instruments to reach into the trachea to retrieve the foreign bodies. But we realize this is not altogether very different than what was done 3 centuries before. For example, Nicolas Habakkuk was a French military surgeon and is credited with publishing the first monograph on tracheotomy. Also described 4 cases, one of which was of a young boy who swallowed a bag of coins for fear of being robbed, and it lodged in his upper esophagus and causing airway distress. Habakkuk is said to have done a tracheotomy on the boy, massaged the coins down into the boy's stomach. Later, of course, the coins were retrieved in a more natural fashion, and apparently the boy went on to heal from this trauma. But the point is that not much had changed over 300 years. And indeed, before the 20th century, the morbidity and mortality of foreign body aspiration was close to 90%. It was a really bad thing to happen. And a good example is found in Morel Mackenzie's 1880 book, Physics, Pharynx, Larynx, and Trachea. He writes, in this case, a boy aged 3 years received into his air passage a piece of bone, which was expelled 60 years later in a fit of coughing. The patient had suffered irregular intervals of hemoptysis, purulent expectoration, and for a long time from cough and dyspnea. But from the age of 28 and 48, he was well enough to do a little work. This was written in 1880. So this was the milieu into which Chevalier Jackson started medical school at Jefferson Medical College in Philadelphia in 1883. And it so happened that he writes in his autobiography, the work of Drs. Gross, Samuel Gross, and Solis Cohen had been interesting, and I had followed it closely at every opportunity during his college years. He graduates in 1888, and he writes in his autobiography, he goes into practice in Pittsburgh, and he writes in his autobiography, in my first year of practice there was an event that called worldwide attention to the specialty of laryngology. And this was, of course, the fatal illness of Frederick the Noble, as recounted by Morel Mackenzie in the book of the same title. Now, Frederick was the heir to the throne of the newly united Germany, and was said to be of a liberal and progressive nature and even temperament. He was nevertheless a heavy smoker. In 1887, he developed severe hoarseness, which progressed rapidly to airway distress. German physicians were called upon to treat him without much success, and his father, Wilhelm II, called upon his cousin, Queen Victoria of England, to send over the best they had, which was Morel Mackenzie. Mackenzie saw the prince, did a biopsy, which was interpreted by Rudolf Virchow as being negative and benign, and nevertheless, Prince went on to need a tracheotomy, and 3 months after his coronation, he passed away from his disease. His son Wilhelm, or Kaiser Wilhelm as he was known, was of a very different temperament from his father. He was much interested in militarism, and the tragedy of World War I is attributed to perhaps this event. Now, Jackson decided that he was interested in laryngology and took fellowship in England with Moran Mackenzie. And this was in 1889 to 1890. And he came back to the United States in 1890 and wrote in his autobiography, 40 years later, I made good use of my time in London. I saw an impractical device designed by Mackenzie to inspect the esophagus. By 1890, I had developed an esophagoscope worthy of the name. This is again from his autobiography. The illustration shows from Mackenzie's pharynx, larynx, and trachea. Jackson, in his autobiography, writes from this period, the development of the esophagoscope brought me a series of very sad cases. A girl 7 years old, emaciated to a skeleton, had been found lying on the floor of a coal miner's shanty. She had not taken a drop of water for a week. When she tried to swallow, she choked, and all the water came back through her nose and mouth. I put the esophagoscope between her parched lips and found a plug of grayish matter, which I removed with delicate forceps. She took a small sip of water. It went down slowly. She gently took hold of my hand and kissed it. Which begs the question, how did Jackson come into his hands with this laryngoscope? And really, this is the story of endoscopy. Now, there's 5 challenges to endoscopy. First of all is utilizing the natural openings of the body, although now we seem to be able to make our own openings and still do minimally invasive surgery. The second one was getting the light, electromagnetic radiation, into the viscera, which then can be transmitted back to the eye. One of the goals was always expanding the field of vision, and of course, freedom from pain was essential. Now, the getting light into a space has been around for a long time. The Egyptians used polished steel mirrors to reflect sunlight into their tombs to paint by. And I took this photograph in 1997 when we visited Egypt, showing the process with which they painted the hieroglyphics within the tombs. They used practical rules of thumb on how to direct the light, and this was the basic form of lighting and illumination until well into the 19th century. True understanding of light really required an understanding of geometry. Geometry, of course, go back to Euclid in 300 BC, but it was not introduced into the European culture until much later, and it came through the work of the Muslim scholars and mathematicians of the Islamic period around 1000 AD. One of the most prominent was Avicenna of Persia, now Iran. He was known as a poet, mathematician, physicist, and again a physician. And he experimented with curved mirrors and lenses to study light and discovered the laws of refraction, which were rediscovered by Snellius in the 17th century. And the law is now named after him. What we do know is that Avicenna used reflected sunlight with curved mirrors to examine various parts of the body, including the ears, the nose, the mouth, and the vagina. It was the primary way of examining patients using sunlight to look in as best as you could until about the middle of the 18th century, when another form of illumination came into use. And this was the use of candlelight reflected through a mirror. Archibald Cleland was a practitioner, and I found a reference to him in the British Medical Journal under the title of Interesting General Practitioners. Now, he was a military surgeon, and quote from the article, during his years in the regiment, Cleland developed several novel instruments which he demonstrated to the Royal Society, including a candle-powered illuminator for inspecting the eardrums. He was also the first British practitioner to catheterize the eustachian tube, and you can see on the right of the illustration, the eustachian tube catheter, and on the left of the illustration, the candle-powered otoscope. The first true endoscope is credited to Philipp Bozzini of Mainz, Germany. He devised another candle-powered device using reflective mirrors within the cavity of the device, as shown here in the, see if I can make this work. Here's the cavity device with the surrounding mirrors, the candles within the center of the device, and you look down the tube with the light going down with your visualization. You can see the various specula that he used, for example, this one for otoscopy. He also had a speculum. Now, I found an illustration of in Morell Mackenzie's book on the use of the laryngoscope, which also is used for indirect laryngoscopy, although there's very little clinical evidence of its use and observation. Now, in the same book by Morell Mackenzie, he describes the work of Benjamin Guy Babington and the instrument that he demonstrated to the Hunterian Society in 1829. And Mackenzie goes on to say, and this is prescient, in this country where the sun very often does not shine brightly for weeks together, the art of laryngoscopy could never have flourished till artificial light had been substituted. The development of indirect laryngoscopy is credited to Manuel Garcia. Manuel Garcia was a celebrity singing teacher working in London. He was originally of Spanish origin. He was born in France, and he was a well-regarded operatic teacher working in the European society. He conceived otoscopy. The legend has it that he was looking in a window and saw his reflection of his mouth through the sunlight that was reflected from the mirror in the glass. And he conceived the otoscopy to use a dental mirror and presented his observations to the Royal Society in 1855 under the title Physiologic Observations of the Human Voice. He became quite famous for this, and this is a portrait of him on his 100th birthday. It's by John Singer Sargent, the famous celebrity portrait artist. He was at this point highly regarded throughout the scientific world as the inventor of laryngoscopy. He died a year later at the age of 101. Now, the original work of Manuel Garcia is shown in the to your left illustration. He uses sunlight in a mirror that he holds in his left hand, and he holds a dental mirror in his right, makes the observation in the mirror. He eventually transferred for examining others using a head mirror and a kerosene lamp, and continued to use the dental mirror, as we all learned in the beginning of our residencies. Unbeknownst about the work of Manuel Garcia, Ludwig Türk, an Austrian neurologist, was also interested in the functions of the larynx, and he built his own otoscope in 1856, a year after the Garcia presentation to the Royal Society. And I was able to find his book from 1860, and it shows the use of the otoscope. He's examining himself. It emphasizes the fact that you got to have good sunlight, as evidenced by the sun kind of streaming through the window. But nevertheless, the device was clearly useful because the observation of the hypopharynx that illustrates his book is excellent and true to reality. Now, Türk was frustrated by his use of lack of sunlight, and he showed his instrument to another neurologist by the name of Johann Cermak. Now, Cermak was another one of these East European polymaths, educated in Vienna, student of Jan Purkinje of Purkinje fiber fame, became a physiologist, neurologist, and was a professor at succeedingly more prominent European universities. And he's really credited with introducing laryngoscopy and laryngology into the mainstream of medicine. Now, what Cermak did was to refine the otoscope of Türk and added artificial illumination in the form of a alcohol kerosene lamp, and published his work before Türk had a chance to do so. the two became bitter enemies and became rivals over priority of the invention. And this became known as the Turk Wars. And it was spread over the medical journals of the era. And of course, the rivalry had the beneficial effect of spreading the discovery of laryngology across the globe. In England, Morel Mackenzie developed an international clientele in laryngology. He was the first professor of laryngology in the UK, wrote The Use of the Laryngoscope in 1865. And in this book, which is where the illustration is from, shows his use of a oxyhydrogen light, along with the precursor to the examining chairs we currently use, although you notice he uses hand pumping as opposed to electricity. In the United States, Louis Ellsberg was practicing at New York University, and he became the first professor of laryngology in the United States. In his textbook, you can see the illustration of his examination using the technique of Zermach, and again using artificial illumination with a kerosene lamp. He's also one of the founders of the American Laryngologic Association. Now, the other next important step that had to occur was the getting patients freedom from pain. First operation under general anesthesia is credited to William Morton at the Massachusetts General Hospital in 1846. And Karl Kohler, who was an ophthalmologist in Germany, recognized the local anesthetic effects of cocaine and published the results of the effect on all sorts of different mucosal surfaces. And every book, if you look in the textbooks of otolaryngology, endoscopy after about 1880, have chapters on anesthesia and the importance of it. And this wasn't the only place things were advancing. All over science in the 1880s, 1890s, it was an amazing time. And this was also the case for electricity. Now, the first interest in electricity goes back to 500 BC to Thales of Miletus, who discovered that if you rub amber with fur, you get a magnetic effect. And by the way, amber in Greek is electron. Eventually became understood what electricity might be, but perhaps the most famous of the early electricians, of course, is Benjamin Franklin, who in 1750 writes, "When rain has wet the kite twined so that it can conduct the electric fire freely, you will find it streams out plentifully, and with this a Leyden jar may be charged. Therefore the sameness of the electric matter with that of lightning completely demonstrated." Now, we know Benjamin Franklin as, of course, one of the founders of our nation, a great polymath, but in 1776, when he was sent to Paris as the ambassador from the newly found America, he was received not as a revolutionary or as a great diplomat or as a great writer. He was received as a celebrity scientist for his work on electricity. And it was soon after that the ability to create electric currents occurred with the work of Alejandro Volta. Volta was, of course, a professor of chemistry and physics at the University of Como in Italy, and he he recognized that if you use two different metals in a solution of the salt, you could create an electric current, and this allowed for greater study of the new force. Experiments with electricity, once this was there was already source of electric current, there came many practical applications. One of them was an important one, and this was made by Christopher Pfaff, a German physician, again, doctor, physicist, chemist, a good friend of Volta and Faraday, and in his day, an expert in electrical theory. He discovered that a platinum wire electrode, when a current is applied to it, will glow for a prolonged period of time. The only problem was it was very hot. Recognizing the medical potential of Pfaff's discovery, Julius Bruck, who was another German physician, dentist, and stomatologist working in Breslau, Germany, devised a device that surrounded the platinum wire with a water-cooled jacket. He called this a galvanoscope. It was the first example of distal illumination used for examining things like the mouth and urethra, although there's little evidence for its clinical use. However, two giants took up the cause. First was Max Nietzsche, who was the professor of surgery in Berlin, is considered today the father of urology, working with the brilliant Viennese engineer Joseph Leiter, developed the Bruck design into a small, practical, water-cooled platinum wire electrode that could be inserted into a cystoscope. And indeed, this is the first functional cystoscope that used distal illumination. Here's your platinum wire electrode. It's being cooled by water surrounding it. The light, to get a view of the interior of the bladder, you need it at an angle, so the light is then cast back down with this prism. Now, here's where Leiter's brilliance came along. He developed the first telescope. Now, these are different than the telescopes we use today. These were actually glass optical telescopes, which gave a somewhat enlarged view of what they were viewing. You can immediately see what the problem might have been with this device, is that you could do very little work with it. It was just primarily for diagnostic purposes. Interestingly enough, a bitter feud arose here again between Nietzsche and Leiter over priority of the cystoscope. However, not to belabor the point of the problem, it became apparent with the work of Johann Michelitz, who was also a well-regarded surgeon practicing in Vienna at the time, and he got Leiter to give him a longer version of the cystoscope that would go down into the stomach. And what he found was that it gave him a good view of what was going on and of the pathology, but he could do nothing in there. So they took a step backwards and created a platinum wire electrode that was in the handle of the scope, and they used a prism then to cast the light down the shaft of the scope into the working channel of the esophagoscope. And this was the first esophagoscope that you could actually do work through. Now, there's a lot of controversy and scholarship of who really invented the light bulb. What I can say is that the mass production of Edison's light bulb starting in 1880 was a historically unique event. It really changed the world in innumerable ways, and its impact on medicine has been enormous. And this was particularly true in the early days of endoscopy with the miniaturization of his invention. Now, it didn't take long. 3 years after the Edison light bulb came out, David Newman was a general surgeon and urologist practicing in Glasgow, Scotland, designed a cystoscope around this small bulb for examining the bladder. And he writes in 1883, the electric lamp is introduced through the urethra without being connected with the battery. It is important that the lamp should be introduced before the circuit is completed, as if this precaution is not taken, the lamp is apt to become heated and may crack when it passed into the fluid contents of the bladder. One interesting fact is that Newman became also an otolaryngologist and wrote a respected textbook on the topic at some point in his later career. Now, direct laryngoscopy was not thought possible because it was not conceived that the oropharyngeal axis could align with the laryngotracheal axis. So it was indirect laryngoscopy that was first being done. However, in 1894, a happy accident in a Berlin clinic at the University of Berlin by a well-known professor there, Theodor Rosenheim, inadvertently passed an esophagoscope into the larynx and trachea and found that he had a perfect view of bronchial bifurcation. He called several people in his department, one might say foolishly, to come take a look what he found. And one of them, Alfred Kirstein, recognized the significance of the accident, and within weeks designed and fabricated a laryngoscope. He used the same handle as Mikulicz, the lighter handle from Mikulicz's esophagoscope, but he used a laryngoscope, which most of us would recognize today as a perfectly functional instrument. Within a month, he presented his findings at the Berlin Medical Society, establishing the early principles of laryngoscopy, many of which we still use today. And of course, this paved the way for bronchoscopy. Now, bronchoscopy is credited to Gustav Killian. He was another practicing rhinolaryngologist in Freiburg, Germany, a former student of Adolf Kussmaul, and he attended Kirstein's lecture in 1895 at the Congress of German Laryngologists. He recognized the importance of Rosenheim in Kirstein's observations, and he hired his clinic janitor to practice intubation of the trachea. Now, this is a photograph taken well into later in Killian's life, where they're reenacting the original bronchoscopy with the original janitor. Interestingly enough, he continues to use proximal lighting, and this is the first foreign body publication. A farmer had ingested a piece of bone with his soup. Listening to his breathing, a wheezing noise could be heard in his right lung area. We used a Mikulicz electric lamp light esophagoscope and forceps to remove the splinter, and this is a photograph from an event similar. Now, Killian became internationally famous. He developed many of the tools and techniques of bronchoscopy, special positioning, including suspension. Some strange reason he continues to use proximal illumination, either with a reflective mirror or a headlight as shown in the photographs. Now, the use of light bulbs, however, spread across the world, and I found this wonderful textbook by Horace Ivins, who was professor of laryngology at the Hahnemann Medical College in Philadelphia. And for example, you can see how he adopted a small dental mirror, with an electric light bulb, which then he used to examine the larynx. This is published in his textbook in 1893. Now, the story now jumps in a big way to, of all places, Rochester, New York, where in 1898, electrician Charles Preston, who's really a electrical engineer, manufacturer of light bulbs, and a traveling salesman all at the same time, he visits Rochester to show his wares to the medical community there, and meets urologist Henry Koch, and they form a collaboration. Koch convinces Preston to further miniaturize the light bulb, and he cuts it down to about 8 millimeters by 3 millimeters. This comes to be known as the minion light bulb. Now, the other thing they did was reduce the amperage. Because the light bulb could be smaller, the amperage could be lower, and you could still get a reasonable amount of light, but the light bulb would be safe near adjacent tissues. But the more important innovation, and this was key, was that they built a separate small channel through which to introduce the light bulb on a light carrier, which could be easily removed should the light bulb burn out. You can put it right back in, and it doesn't interfere with your working channel that you needed to do surgery through. The cystoscope was patented in 1899. Other specialties quickly recognized its utility, and Koch established the electrosurgical instrument company in 1901. It is still in business in Rochester, New York. And it was a delight getting in touch with their current president, finding more about Henry Koch. Now, as I said, the innovation spread rapidly. Max Einhorn was professor of medicine at the New York Medical School, one of the founders of the American Society of Gastroenterology. He writes in a 1902 publication from the New York Medical Record. More recently, the Electrosurgical Instrument Company of Rochester, New York, has succeeded in manufacturing the so-called cold electric lamps. They generate very little heat without interruption of current. These lamps have been used for urothroscopy and proctoscopy. I've constructed similar instruments for the esophagus. It is again in this milieu that Chevalier Jackson returns from London in 1890, establishes a practice of otolaryngology and surgery in Pittsburgh, and quickly develops skills, experience, and confidence, and begins publishing his work in the medical journals of the time, and of course he gains national recognition as a consequence. In 1907, he publishes the first of his 10 textbooks that he used to write over the course of his career. It's entitled The Tracheobronchoscopy, Esophagoscopy, and Gastroscopy, and it's dedicated to the father of bronchoscopy, Professor Gustav Killian, as a token of esteem. It is the first book in English on the topic. It describes all of his techniques of aerodigestive endoscopy. And most importantly, he shows off the novel instruments that he's invented, establishes the role of radiography within endoscopy, and the importance of illustrating what he's seen in order to subsequently teach it. All of the initial instrument uses the same instrument for bronchoscopy, esophagoscopy, and gastroscopy. Eventually, it becomes more specialized. But notice again the anterior commissural laryngoscope. You recognize that today in the operating room. And of course, he develops the slide laryngoscope, the bottom slide laryngoscope, which allows exposure to the larynx and then allows you to introduce a bronchoscope, esophagoscope, or gastroscope. He devises specific instruments for foreign body extraction specific to the foreign bodies. Perhaps the most novel is a safety pin closure. The body produces biopsy forceps, suction aspirators, and works with the engineers of his time to develop reliable battery sources. He demonstrates how to position the patient, the surgeon, and his assistant for each type of endoscopy. In this case, the patient is recumbent, and he emphasizes the importance of the assistant and how the assistant, look at those hands, how the assistant is holding the patient just right to facilitate the endoscopy so that Jackson can see what he needs to see. He provides a rationale for preoperative radiographic diagnosis so he knows where the foreign bodies are, the importance of having maximum information before you start your surgery. And he's the first to develop radiologic localization. Today we would call it navigation, but I think it's from these concepts that his adage, which I learned a long time ago, 2-minute preparation, 2-hour surgery, 2-hour preparation, 2-minute surgery. I think some of you who've worked with me know this, the importance of this. He provides vivid drawings in order to facilitate and flatten the curve of learning for others, whether it's in bronchoscopy, and you can look at these illustrations today and recognize papilloma. You can write on gastroscopy, you can see the rugae of the gastric tract, and you can see candida or polyps within the esophagus. You recognize them today. And he begins his collection of foreign bodies, which ultimately has over 2,000 objects. These are, of course, stored at the Mutter Museum, which is part of the University of Pennsylvania in Philadelphia. And if you're ever in that beautiful city among its many great museums, this one is worth seeing. Again, he's unique. He establishes his own metalworking shop, so he develops the prototypes of the instruments that he wants to be using. And then he commits his whole life to teaching. He's wonderfully ambidextrous, so he can talk and draw at the same time with 2 hands and provide the illustrations. The illustration, for example, up on your left, upper left, from 1902, it's from one of his lectures. We had it in the Otolaryngology History Museum at the Academy, and it shows him doing his drawing during a lecture. Another incredibly important aspect of what he does is he establishes the concept of doing endoscopy on anesthetized animals in order to gain the skills of endoscopy. This is what I taught for years in Albany at the Cleveland Clinic. When I got here, I was appalled that anybody should want to do that to animals, so we dropped it. But that's how we learn. Now we have simulation. And finally, he works with the George Pilling Company in Philadelphia to develop and manufacture the instruments and endoscopes he's developed over many, many years. And this makes them obviously available to the rest of the medical profession. In 1917, 10 years after the publication of his first book, he founds the American Bronchoesophagologic Association, and institutionalizing the specialty, which we now still have today, and which is still a very active and wonderful organization. Now, in 1977, I began my residency at the University of Texas, and we learned endoscopy with the Jackson Pilling set that you see in the illustration. This is what I learned on. And it wasn't until my senior year, chief year as chief resident that we got the early parts of the Stortz equipment that you're all familiar with proximal, with distal illumination as well as distal viewing. If you think about it, these instruments were developed to begin with right around 1900. To me, the longevity of this accomplishment is what impresses me the most. Now, Jackson is a giant among 1,000 fathers, and I've tried to show some of them to you, tell you some of their stories. And I know in these days, telling a paternalistic story is not very fashionable. And the only thing I can say about that, this was the reality, and perhaps if the other half of humanity had been involved earlier on, the story wouldn't have taken so long. Jackson, for me, profoundly demonstrates the aphorism by Sir Isaac Newton: "If I have seen further than others, it is by standing upon the shoulder of giants." Chevalier Jackson used the novel technology of light bulbs to display his genius. It was a springboard for a wealth of innovation that we all still use today. In the process, he saved thousands of lives. He democratized the practice of endoscopy. He made it accessible to plebeians like us, and the ordinary like us. And he taught many generations of surgeons those skills necessary to save lives. We carry on his legacy. To me, Chevalier Jackson was a giant, and to me he was a hero. And he's a man worthy of remembering because he was so important to the practice of what we value so highly. Thank you for the opportunity to tell you this story. Actually, we have a little time for questions and answers. Happy to talk about this. It's one of my favorite topics. All right.
So Peter, there's a lot of the things that you showed pictures of today we all recognize, and we've all used Jackson slide scopes, and like you mentioned, there's not a lot of differences between what we're using today and tomorrow and what was used, 100 years ago. So what do you anticipate the direction of tomorrow?
Well, first of all, major step forward was the development of the Hopkins rod telescope, which uses air as the lensing material and gives you a much brighter view. That's why you can do the surgeries you now do today endoscopically. Carl Stortz, of course, then supplied the cold light source, fiber optic light source to the Hopkins rod, and then developed the instruments necessary to do the high-end sophisticated work we can now do endoscopically. I just had my aortic valve replaced 3 weeks ago, tomorrow. And they used a minimally invasive technique based on imaging. Well, it's not light, it's electromagnetic radiation. It's just of a longer wavelength to visualize what they were doing. So the concept of minimally invasive surgery is here to stay. We don't have to do endoscopy on animals anymore. We can do it safely. For example, the work of Tullio's doing with simulation. We have greater and greater, just like the James Webb Telescope gives us a bigger picture of the universe, and the Hubble did. Similarly, our new technologies give us bigger pictures and more broadly, a broader understanding of what we're looking at. That's what I see in the future. It's not going backwards, it's going forward.
Right.
Thank you all for coming.